Picture this, you're flying at 12,000 feet, everything seems normal, and all of a sudden your aircraft starts to lose performance. You look outside and see that your wings are coated with ice. Scary, right? But what if I told you that just knowing few things can help you save your life and also ace your Dgca exam? That is what we are going to uncover today. Stay with me, and by the end of this video, you will have icing mastered like a pro. Here's what we'll cover today. We're going to understand the types of icing. There are mainly two types of icing, airframe icing and engine icing. Airframe icing, we're going to understand what a hoarfrost is, a clear ice and a RIME ice. In engine icing, we're going to understand what a carburetor icing is. Secondly, we're going to go through how does icing form and why does it matter for pilots. Then we're going to dive into how to identify icing prone clouds and their temperature ranges. And lastly, we're going to go through some tips, tricks, and I'm also going to give you a master mnemonic to ace Dgca questions on icing. And yes, we've got a Dgca style questions and downloadable notes waiting for you at the end. So, are you ready to take off? So before we jump into what actual and different types of icing are, the first thing we need to understand what a supercooled droplets is. So high up in the sky, where temperature plummet below freezing, not everything behaves as you might expect. Meet the supercooled droplet. A tiny drop of water that stays liquid even in temperatures as cold as minus 40 degrees Celsius. How is this possible? Unlike ice, supercooled droplets lack a nucleus or particle to help them freeze. So they remain in a liquid state, ready to freeze instantly upon contact with the solid surface. So when an aircraft encounters these droplets, they freeze on impact, forming dangerous ice on wings, engines, and sensors. This is why pilots are trained to recognize and avoid icing conditions. So what is icing and why is it dangerous? Imagine this. You're cruising smoothly when your aircraft starts behaving unpredictably. Icing can reduce lift, it can increase drag and compromise your safety. Sounds terrifying, isn't it? Let's simplify it. So now let's jump into airframe icing. In airframe icing, as I told you at the start, we have hoarfrost, clear ice and RIME ice. Let's get out of the way the easiest one, which is a hoarfrost. So nature paints beautiful patterns with frost, but in aviation, it's a sign of caution. Let's talk about hoarfrost. Hoarfrost forms when water vapor in the air skips the liquid phase and deposits directly as ice on a cold surface. This happens when the surface temperature is below freezing and the air is calm and humid. For pilots, hoarfrost is more than just a winter wonder. Even a thin layer can disrupt the smooth airflow over the wings, reducing lift and increasing drag. This can affect takeoff performance and safety. That is why it is essential to thoroughly remove frost before your flight. A small oversight can lead to a big consequences. There are two types of icing, mainly two types of icing. The first one, clear ice, and the RIME ice. And let's meet the culprit. So the first clear ice is also known as sometimes glazed ice or translucent ice, or you can also call it as translucent RIME. This forms from large supercooled water droplets that freeze slowly, creating a smooth glassy surface. It is heavy, stubborn, and clings to your aircraft like a bad habit. I'm sure you know what bad habit I'm talking about, don't you? Did you know that carburetor icing can even occur on a sunny day like this? Surprising, right? Let me know in the comments if you know the reason for carburetor icing on a sunny day like this. Second one is RIME ice. This RIME ice is formed by small supercooled water droplets that freeze instantly. What happens in there? Air gets trapped, making it light, brittle, and easy to break. Think of it as a fragile sibling of clear ice. I'm sure you have a fragile sibling, don't you? जो हर बात पे रोता रहता है. So you would ask me, sir, how would I distinguish between a clear ice and a RIME ice? देखो द इजीएस्ट वे, तुम लोगों ने फ्रीजर तो सभी ने खोला होगा. सो व्हेन यू ओपन अप द फ्रीजर देयर इज एन आइस क्यूब, राइट. वो जो आइस क्यूब है ट्रे में, इट इज हार्ड. कभी उसको हाथ से तोड़ के देखना. दैट आइस क्यूब यू विल नेवर बी एबल टू ब्रेक. दैट इज, यू कैन कंसिडर इट एज अ क्लियर आइस. और वही क्लियर आइस को हम कहते हैं ग्लेज्ड आइस और ऑल्सो ट्रांसलूसेंट राइम. मतलब जो भी चीज ट्रांसपेरेंट है वो क्लियर आइस है और हार्ड है और हेवी है. और ये सब क्यों है? क्योंकि उसमें एयर मॉलिक्यूल्स ट्रैप्ड नहीं है ना. वेयर एज जो फ्रीजर के साइड में एजेस है, उन एजेस पे जो एक बारीक बारीक आइस होती है, दैट इज राइम आइस. इट इज ओपेक, इट इज नॉट ट्रांसपेरेंट, इट इज ओपेक. एंड क्योंकि उसमें एयर मॉलिक्यूल्स ट्रैप्ड हैं, इट इज लाइट, इट इज ब्रिटल एंड इट इज easy to break. So now we know what a clear ice is and a rime ice is. Airframe icing just does not happen on its own or anytime it feels like or anytime the temperature goes below 0 degrees Celsius. Airframe icing occurs only when there are certain conditions meeting, like there should be visible moisture, temperature ranges, aircraft surface temperature, supercooled liquid water, and flight through that icing zone. So when and where is icing most likely? Because as a pilot, we need to know where to expect it the most. So here is the icing temperature playbook. So let me go ahead and tell you that severe icing is normally found from the temperature ranges from 0 degrees Celsius to minus 7 degrees Celsius. Would you imagine that? Normally you'd think, sir, severe icing hai to jitna zyada thanda utni zyada icing, utni zyada severe icing. Not really. Severe icing, the most severe icing is found during the first start of the range, which is from 0 degrees to minus 7 degrees Celsius. Then we have moderate icing, which is minus 7 to minus 12. Light ice, minus 12 degrees to minus 20 degrees Celsius. And to your shock, it is extremely or very light ice that is found at the extreme end of that temperature bracket, minus 20 and minus 40 degrees Celsius. And again, that icing temperature playbook given on the screen, make sure you learn and memorize this. Not just this is going to help you to save your life in sky when you're flying, but this is the important question that Dgca loves to ask, right? Okay, we know the temperatures now, right? Now we need to find out in which types of clouds will you find this icing. Yeah, sir, temperature to aapne bata diya, right? You have told me that at these temperatures I'll find icing, but it's not just, it's just 0 degrees Celsius or ice jam jayegi. No, I need to have that certain amount of clouds, certain types of clouds where I'll find most icing. And being a good aviator, I need to know what those clouds are. And again, this is the question which Dgca loves the most to ask, that in which type of clouds the icing will be found the most. So first, when we talk about cirrus clouds, and you must have watched my previous videos, if not then please go ahead and watch the cloud video first. But in cloud videos you would see that the cirrus clouds are the top layer clouds, right? So cirrus, cirrostratus or cirrocumulus. The first one, it is mostly just ice crystals and it's not a big deal, it's no biggie, right? The second one, the middle layer clouds, let's say, that is altostratus or nimbostratus. These clouds have supercooled water droplets or supercooled ice crystals, and they have light to moderate icing. Then comes the most severe icing. तो सर ऑल्टो का हो गया, लोअर लेवल पे आप बोल नहीं रहे हो. Where do I find the most severe icing? So the most severe icing is in towering cumulus clouds, or we also call that as cumulonimbus clouds. So in these clouds, the icing can range from light to severe, and that is especially when the temperature is above minus 20 degrees Celsius. Now remember, above minus 20 is not minus 21. Above minus 20 is going back, minus 19, minus 18. And remember, severe icing is found where? Between the range of 0 to minus 7 degrees Celsius. So below that, severe icing is insignificant. Yeah? And let me tell you, I've got a very good mnemonic for you to remember this. All you have to remember is just this one line. Careful aviators never take coffee breaks. Now you'll see it on the screen. What I mean by that, careful is like all the C clouds, which is cirrus, cirrostratus, and cirrocumulus. Aviators is basically your altostratus, altocumulus. Never take coffee breaks. So never take coffee breaks. TC. What is TC? TC is towering cumulus, and coffee breaks CB. Cumulonimbus. So remember this mnemonic, that will help you a lot in your aviation exam. Careful aviators never take coffee break. Now I'd like you all to pause the video And there are some DGCA type questions on screen. Try to answer them and drop your answer in the comments again, but you'll see the answer. If you want to find what the correct answer is, that is in the description. I've left it for you. Now that you know how icing works, here's the real question. Do you know how to deal with thunderstorm in flight? Don't miss out our next video where we dive into easy to remember strategies for thunderstorm and how to handle hazards associated with thunderstorm like a pro. Click here to watch. And don't forget to download today's notes for quick revision. Let us know in the comments below what other topics do you want to know and learn about. Let's ace the sky together to my future captains.